Hello, I'm Abdul Raheem and ninepointer from IIT Bombay. In this video, we will be solving a previous year question from ordinary differential equation. This was the question paper of a quiz that was held early on in the course based on some initial topics from ordinary differential equations. And in this video, we will be solving the final question from that quiz. Okay, the eighth question is a solution of solutions f comma g of y prime plus p of x into y equal to 0 such that Wronskian, W denotes Wronskian of f g at x is identically equal to 1. We have to select whether this statement is true or false. That is, we are given a standard differential equation with the coefficient of y prime being 0. And we are asked if there exist two solutions f and g such that Wronskian is identically equal to 0. Okay, Wronskian at any value of x should be equal to 0. If such a thing exists or not, that we have to find. Okay, can you see any speciality in this differential equation? It is just that the coefficient of y prime is 0 and that will help us significantly. Okay, now let me just tell you what actually Wronskian is. I think you will be quite familiar with that, but Wronskian means Wronskian of two functions f and g means it's the determinant f prime g prime written in this form. That is actually f g prime minus g f prime. Okay, in this case f and g are two solutions of the given differential equation. Okay, now what we have to solve is Wronskian being identically equal to 0. Sorry, identically equal to, in general we can say it's identically equal to a constant. Okay, if something is identically equal to a constant, we will have its derivative being identically equal to 0. So that will be a good condition which can help us in proving this. Okay, so I will just find the derivative of Wronskian. The derivative of Wronskian of f g at the point x will be equal to the derivative of this. What will be that? F into the derivative of g prime, that is g double prime, plus second function g prime into derivative of first, that is f prime. And I will put a minus symbol. And what is the derivative of g f prime? So g into derivative of f prime, that is f double prime, plus second function f prime into first function's derivative, that is g prime. Okay, you can see that the term g prime, f prime, g prime are common on both sides. So we will have f g double prime minus g f double prime. But these f and g are actually solutions of the given differential equations, right? So the given differential equation is y prime plus p of x into y equal to 0 or y prime plus py equal to 0. And f and g are two solutions. That means they should satisfy the given differential equation, and we will have f prime plus pf equal to 0 and g prime plus pg equal to 0. That means they should be identically equal to 0. Okay, these are all functions. Okay, not just numbers. F prime is a function, pf is another function, so they are identically equal to 0. From these equations, we will get f prime is equal to minus pf and g prime is equal to minus pg. Let me just substitute them here in place of the derivative of Wronskian. F into what is g double prime? That is just minus pg. Okay, now we have a minus sign here and a g here. What is f double prime? F double prime is minus pf, so this will become plus and we will have pf here. That is minus fpg plus fpg. That is actually identically equal to 0. What we got here? We got that the derivative of Wronskian, I have just simplified my notation, derivative of Wronskian is identically equal to 0, which means Wronskian is identically equal to a constant. Okay, so we have found some constancy to which the Wronskian is identically equal. But what we need here is, we need the Wronskian to be identically equal to 1 itself, not any arbitrary constancy. It should be identically equal to 1 itself. For that, scaling will help us. How? Yeah, the basic idea is, if f and g are two solutions of the given differential equation, any constant, non-zero constant, af or ag, in general we can just put another constant and say bg, these should also satisfy the differential equation. Yes. So using that, we will say that this can be identically equal to 1. How do we exactly do that? We need an equation here, or we can actually derive a simple equation here to help us do that. Okay, let's just calculate what is the Wronskian of af bg at the point x. Okay, that would be af and the derivative of af will be af prime. We will have bg here and the derivative of bg as bg prime. Remember, a and b are just scalars, just numbers, they are not functions. Okay, now the Wronskian will be ABFG prime minus ABF prime G. That is just AB into FG prime minus F prime G. That is equal to AB into the Wronskian of F and G at the point X. Right? FG prime minus G prime FG prime minus GF prime. This is actually our Wronskian. Okay, so we have actually got that this Wronskian is actually equal to what? This is actually identically equal to some constancy, but we need it to be identically equal to 1. Okay, now we have Wronskian of AF and BG to be identically equal to ABC. But what are these A and B? They are just some scalars, right? And can we actually put them equal to 1? That is C being equal to 1 by AB or AB being equal to 1 by C. Is that possible? Yes, we have a constant here, right? So in that place, I will select A and B, so that the product of this AB is 1 by C. This A and B are any scalars, any arbitrary real numbers such that they are not 0. Okay, so I can choose A and B in such a way that their product being actually equal to 1 by C. In that case, what will happen? My Wronskian will be identically equal to 1. Okay, so in that case, we will have Wronskian of AF BG X being identically equal to 1. But the issue is, you might now say that we needed the Wronskian of FG and X to be identically equal to 1, but we have Wronskian of AF BG and X identically equal to 1. Is that really satisfied? Just remember, just think, what is this F and G? They are just two arbitrary solutions of the given differential equation. Okay, we actually took F and G, but just took their scalar multiples, and they are also some solutions of the given differential equation, right? So it's okay to take AF and BG in place of F and G because they also do satisfy the differential equation. Okay, so we have got Wronskian of one function with another function, both those functions being solutions of differential equation at any point being identically equal to 1. Okay, so which means the given statement can be attained, and so this is a true statement. I hope that it was clear. If you have any doubts, feel free to ask in the comment section. And that's all. Thank you for watching. Here ends the playlist of quiz questions from ordinary differential equations. And in the next video, we will be coming with the end semester question. Okay, the questions with high weightage in the entire grading. We will be coming with the solutions of those questions in the upcoming videos. So stay tuned to the channel, subscribe to the channel, follow our Instagram and Telegram channels in order to get live updates. Thank you and bye.